Yeah, be sure and put them in the Petri dish and not the lid. That's the lid that you're putting them in. The Petri dish is the deeper part. The lid is shallower. Yeah, so make sure you're putting them in the deeper one because we've got to add some water to it. So when we get ready, let me know. So they're ready to go over there, ready to go over there. Okay, great. Everybody's ready. So now what we're going to do is we're going to take the move, and as quickly as possible, we're going to take our dropper and add the water to the Petri dish. You got to do it pretty quick. In fact, if you want, you can actually tilt it like this. And just kind of pour it in there. Like that. Fill it up as quick as you can. Might go ahead and let them just pour it. I was thinking the dropper, but the dropper is going to go so slow, it's going to make everything mix up while they're trying to get in there. So let's just pour it. If we spill a little bit on the table, it's no big deal. That's what our lab's for.
Yes.
Just pour it into the center and let it fill up with water. Yeah, there you go. And then just let it sit there for a minute. And start watching what's happening. Can you see what's happening in my picture? So you pour it in there. You see what's starting to happen? As they sit in the water, notice that the colors, the dyes that are in there, are beginning to dissolve and come out into the water, right? Okay, so just watch them for a minute. Don't move them around. Now, as they move together, remember that static electricity we talked about? Well, these molecules that make up these dyes, they have a certain amount of attraction. Now, it's a great big long word called intermolecular forces, but it's basically the same thing as that static electricity you were talking about that's going to make them attract to each other differently. And as a result, notice those that are similar like each other better than those that are different. So notice how as they begin to move out into the Petri dish, that each one establish their own individual color. Can you see that on yours? Miss Mindy, why don't you go around over there and take a picture of some of theirs? Theirs are coming out really good. Yeah.
One drop.
Just put you one drop of water right on top of your black dot. 1, 2, 3, and add it on there. And just keep doing that till the water begins to move out on the paper. What do you notice is happening?
Did you get a drop?
He didn't get a drop.
Is the black dot just staying a black dot in place? No, it's beginning to move out, isn't it?
And there's some water. You can have
A lot like our Skittles, the black dot's beginning to move, isn't it? Except in this case, we weren't trying to run the colors together. We're trying to see if the colors would separate when they get wet, right? Okay. So you got it added in there. You're getting a good run. Add a little bit more. See if we can run it almost all the way out to the edge.
Try to get yours all
See if
the
we
way
can
out.
run it almost all the way out to the edge.
a switch. There.
See if you can get enough water in there to make it run all the way, almost all the way to the edge. See who gets to the edge first. Hers is off to a really good start over there.
Yeah, there you go.
How'd this one
We
come?
got a contestant here.
All right. His is moving on. His is moving on. They're almost there, right? Yeah, I want to just kind of separate out.
Okay.
Good. We got to let them move almost all the way to the edge so we can answer that first question on our experiment. Okay, so hers is almost there. Is this almost there? Kind of interesting. His spread more in this direction than they did in another direction, didn't it? You notice how all of them spread a little bit different depending on the shape of your dot?
Yep.
So
You put one
more
little drop
round
and
your
then
dot
count to
is, the more
three
they go in one
and then
direction.
throw another one.
If your dot wasn't real nice and straight,
Keep doing
you go
it
in a
to your
different
little
direction.
droppers.
Okay, so here's where we collect our data now. Once you
There you
got
go.
the colors out there, use your pencil and just go through and record right here, starting from the one that's closest to the center. In other words, whichever color you see closest to the center, write that down. What are you seeing as being the closest one to the
What are
center?
these back in here?
I think I would see what looked like yellow.
Yeah, that's fine.
I say
That's
blue.
what's scared. Yeah. Yours looks really nice.
Remember, just keep that up till it gets almost to the edge.
What if mine just mean that the blue ink is made of light blue and purple ink to get the color together?
I don't know about you, but I've already noticed something kind of interesting. Which one of those three colors we put on there wasn't really a pure color? Have you noticed that yet?
The one you just
Oh, have you noticed that several of the colors may not have been a real pure color, right? Yeah. Where's the green coming from? Anybody know? Okay, we put green on there, but where did the green one go? I'm not seeing that much green anymore. It's beginning to fade out, right? Does anybody know what two colors you mix together to make green? Blue and yellow, right? So somewhere in the middle up here, we're just going to kind of take this and just sort of do this to it. Like putting a big smiley face on it. And then that's going to show us where in a moment we're going to set our eyes right inside that circle. Not yet, but in a moment we're going to put our eyes right inside that circle when we get ready for it. So now, let's see. We need a cloud. What were clouds made out of again?
Water.
Water vapor, right? So, to create our water vapor, we're going to also create not only the water vapor, but we're also going to create an acid vapor at the same time to see if the cloud captures that acid vapor. So what you need to do is take each of your solutions, not the universal indicator, don't use it yet, leave it over to one side. The other two solutions, take your container and just put a couple of drops. Now see, here's that thing about the Petri dish that's kind of neat, is you notice how that drop stays right dead center? It doesn't spread out. Remember I told you the Petri dish has that static electricity? Well, that static electricity attracts the water droplets and causes them to draw in, and that makes the water droplets stay in place. So I'm going to put a couple of drops. If you happen to put 3, well, it doesn't hurt anything. So just a few drops of that. And then we're going to take our other solution and put it right on top of it, like this. And as soon as you do that, put your lid on it. Because if it gives off any acid vapor, we don't want our acid vapor running off. And then we need that higher elevation cold to make that cloud condense. So you're going to set your dish just like that. So you're going to have a couple of drops of each solution down in the center. And then put your lid back on it and then put your ice above it just like that. Now we need to let that set for just a few moments. So I'm going to get everybody doing that. We've got plenty of Petri dishes, so yeah, several packages of them.
Are we putting in our icing on top of this?
Yeah, the ice goes on top of the Petri dish, right inside your circle that you drew.
Okay, now you have to kind of let it sit there for about 5 or so minutes. So we're going to have to let that ice sit on it for a few minutes because the cloud has to have time to form. If you want to kind of see what's happening, you can kind of raise it up. Oh, look at there. Mine's making a cloud already. See how it's getting that condensation on it? So I'm starting to get a cloud on top of mine. Are you guys getting one on yours? Starting to make that cloud on it? Good deal. We'll give it a few more minutes to finish capturing the chemicals, and then we'll test it to see if it actually got caught up in the cloud or not.
Do you want to sit down? Do you want to sit down?
Yes, please.
When we're using the indicator?
Huh?
When we're using the indicator?
In a moment. Now, while you're waiting for your cloud to form, be sure and notice the big circle down here at the bottom. It wants you to make a sketch of your cloud using the small, like little dots to represent your water droplets. So you can kind of look at that, see what that cloud looks like, and kind of draw it down here. So we can do that while we're waiting for it to make a really nice sized cloud.
It's more focused on the outside than the inside.
Now you get the part that's not quite as much fun in science. Oftentimes doing the scientific stuff, you have to sit and wait on it. So that's why you have to wait just a few minutes. We won't have to wait too long, but just a few minutes.
Some reactions and later stuff you have to wait like days. Some weeks for it to happen. Yes, 4 years. Riley, did you know what I was singing a second ago? Really?
Uh-huh.
What was it?
Okay, so we probably are ready now. So now we're going to, this next part you have to do pretty fast. So make sure you have your indicator ready, because we made such a small cloud that when we open it up out of the air and we take the ice off of it, it's so warm in here, it's not going to take it very long to evaporate, is it? So it's kind of like when you see a cloud coming over the horizon lately, and it's so hot here, and you're sitting there watching it, and all of a sudden you look up and it's gone because it hits that warmer air and it just doesn't rain, it just sort of goes away. Well, we have to be careful our cloud doesn't do the same thing. So in order to test it, to see if it came in, remember what we're going to do. We're going to add our universal indicator to it, and then what we want to observe is, did it stay kind of green color when we added it? Did it go this way towards the blue, or did it go this way towards the red? And then that will be our evidence as to whether or not it also captured the chemicals. We know that we made a cloud, but did the cloud also capture the chemicals? So we're going to take our ice off of it, and then just turn your lid over and add a drop or two of your indicator to the cloud. Now, I don't know if you can see that with my big hand in the way or not, but did you notice mine turned red? Now, I'm not putting any water in it at this point. Now, so this is how you're going to tell whether you got everything deep enough or not, because here's what we want to do with it. We're going to take this and we're going to slide it, find that little hole. Remember I told you to make sure if you have a little hole in it or not? So find the little hole. So it might be a little hard to spot. And just slide this in through that little hole. Push it in almost all the way to the other side, so that it looks something like that.
If we can see the top of the pipette, do we need more icing?
Yes, if you can see the top of the pipette, add a little bit more icing in it. You should not see the top of the pipette. So if you can still see that's why I said that's how you'll know whether it's deep enough or not. So everybody's got it in there, kind of, sort of, maybe. Somebody that didn't do that one time, and they were really good at booming, and their volcano went all over their face. So yeah, we don't want icing all over our face. So put this up here just in case. So just in case you boom it so hard that it just blows it up in the air, we want to catch it. Most of the time it doesn't, but every now and then I've seen them do that.
Yeah. We're not putting it on top, we're holding it above.
Yeah, we're just kind of, it's mostly just as a shield for you, just to make sure you don't get it on you. So what we're going to do then is to make it erupt, to give it our pressure. You see see what we put here? Our syringe. What do you think is going to happen if we mash it? It's going to cause pressure, isn't it? And we want to cause the pressure, like in a volcano, to be really, really fast and really, really hard. So here's what we're going to do. We're going to take our fist like this, and we're going to go boom, like that. And then draw it back a little bit. Boom, like that. Now, don't know if you can see mine's not showing up real well at the moment on top of that. Add a little bit more light to it, see if that helps. But mine made a really pretty good size hole in it when I did that. I didn't get too much stuff on the lid, but I got a really nice size hole in mine. And I'm going to move it back a little bit and kind of turn it to one side just a little bit. And I'm going to hit mine again. Boom. And then I'm going to do it again. And finally, right before I take it out, one more time. Now, I don't know if yours did or not. You're going to drop your golf ball down in it so that it strikes the earth. If you happen to miss, it's okay. You can try again. Boom. Oh, you got a good one. Strike on the first time. There we go. Boom. You got a good one. All right. So now, very carefully, do this next part very carefully. On your next part, what you want to do is, as careful as possible, take the edge of your golf ball and try to lift it without pulling the icing up with it. Now you can put it back up on the table if you want now to get it out. Yeah, so, now, yeah, so you got one. See, notice how it pulls it out sideways if you're not real careful. And what we're looking for is when it hits, it makes a big indentation on it. Did you see that? So it makes a big dip in it. Kind of the shape of the golf ball, doesn't it? But notice how it blew everything out, not up. See how this one is, we're going to hold our popsicle sticks kind of on each end like this. If they're too long for you, you can break it off a little bit. It's okay. Or if you can't hold them like that too well, you need to break them off and make them a little shorter to be able to hold them. Okay, like that. Now what we're going to try to do with them is this. We're going to try to take them and use them like, kind of like snow plows. Just kind of like those two pieces of land crashing together. So what we're going to do is put them on either side in the middle like this, and then basically just push and then pull them up. Like that. So you just push it together, pull it up. A river. So what we're going to look at is how do rivers change the land? We looked at how pressure changes it. We looked at how things coming crashing to earth change it, right? We've looked at how when the land smashes together, how that changes it. And this last one is, how does flowing water change the way things look? And so what we're going to do is just simply hold our dish up kind of at an angle like this, and then take your dropper of water and just drop it down so it runs through your river. Just kind of run it down through there. Maybe do 2 or 3 droppers worth of it. Just going to run it down through there. Now, I don't get enough contrast on this really for you to be able to see it very well. But what I want you to do while you're just holding it is, how many of you noticed is the water And then we're going to put 2 rose petals in it. Now, if they're too big to fit in very well, it's okay if you need to cut it down or take a little bit of it off. You can do that. So like this one's a little bit large, so I'm going to kind of take it and make it just slightly smaller. Because I'm going to put 2 different rose petals in here, like this. Over in the other one, I'm going to do the same thing. A pepper, a carrot. It's okay to put them out along the edges so that you have plenty of room. A piece of tomato. And 2 rose petals. Like that. So, notice I have a pepper, a carrot, the tomato, and 2 rose petals. So everybody's got your setup like that. Let me know.
We're good.
So we're good? All right. Now, remember I said not only are we going to look at what happens if they don't have the same kind of protection, like for example, will the part of the tomato that's exposed react different than the part of the tomato that's not? Okay? But also, what would happen, let's say for example, if the plant were damaged by bugs or by insects, and that outer protection or that outer coating was lost? Say for example, it's kind of like you. When you go out and you play, you get in the dirt. Well, there's bacteria and there's germs in the dirt, right? Well, why don't you get sick every time you play in the dirt? Because your skin, your outer coating, is designed to block those germs out. But that's why, like you have a cut on your finger and you go out and play in the dirt, then sometimes that'll get infected and you have to get medicine on it and do that because it's sore and it hurts, right? Because once you damage this outer surface that's designed to keep you safe from things out in the environment, then those things can get in and cause problems, right? Well, the same thing can be true about plants. And so we're gonna watch that. So what we want to do with our control group is we also want to examine a damaged plant. So find a toothpick in your box. If your box doesn't have one, I've got a couple extra stuff here. Somebody needs it. They're probably going to be in a little plastic bag like this, because I put them in there to keep them from just going all over everywhere. And I got some extra ones up here if you need it.
Yes.
And what we're going to do is we're going to damage one of our rose petals. So I'm going to take just one of the rose petals out of here, and what I'm going to do is I'm going to take my toothpick and I'm just going to poke some holes in it like that. So I'm just going to poke a few holes in it.
To both rose petals in one dish?
Huh?
To both rose petals in one dish?
Now, just do one petal in one dish and put it back, and then take another rose petal out of the other dish, because remember, if it's going to be a control group, what has to be true?
To be the same.
Exact same conditions, everything except what? The acid rain, right? Otherwise, the conditions need to be exactly the same. So then I'm going to poke a few holes in this one. And I'm going to place it back in my container. So now notice we've got some things that have skin on one part and no skin in other parts. We have other things that are mostly just a big heavy skin. We have the rose petal not damaged. We have the rose petal now damaged, right? So now our group is ready to see how will all these different things be affected by our acid rain. So now, one of the things we want to do is, in order to be able to tell what's going on, is we're going to take a little bit of the phenol red. That's the little dropper bottle you have that has the red stuff in it.
Or don't have. We goofed. We didn't get everything out. See, I told you we were
Yeah, so kind of push the plants back up against the edge to make sure you have room to put everything. Now this next part is kind of important because we've got to have room to put everything in and make sure it works right. So the first thing we want to do is we want to make sure that it's actually generating acid rain in our test group, right? So to know right away that it's working and that it's producing the acid, we're going to put the phenol red. But what you want to watch for is we want to put it not dead center, because that's where we're going to put our reaction. That's where our acid rain is going to be produced. We're going to put it just a little bit off center over here, like this. Not all the way back. We're just going to kind of put it just kind of off center like that.
Yeah.
You get in the way?
No, you have it focused on the control group.
There we go. So we're just kind of putting it, so here's the middle, and we're just kind of putting it off to one side, just a little bit. Now that will tell us immediately if the reaction is taking place or not. Now, there's one other thing that we need to know that's important too, doesn't it? Not only that it's generating the acid, but that everything got exposed to it, right? Because what kind of change would it do if the acid rain never actually got to it?
Nothing.
Nothing, right? So the control group and the test group would be the same if the acid rain never got there, right? So we need some way of being sure that the acid rain actually got there, don't we? So to tell us that, we're going to use the little green indicator, and we're going to put it over to the edge, way out by the edge, like this. That way we'll know that our acid, when that green changes colors and goes away and is no longer green, we'll know that it has completely and totally reacted, right?
And this is just for the acid rain.
This is just in the one where we're going to put the acid rain. One of the indicators is so we know right away that it's working. The other indicator tells us it's saturated the whole container and that it's gone all the way to the edge. So we'll know that it's had time to get there and fill the whole container up. So now, for our control group, remember we don't do anything to it. That's so we can compare it when they get through running, right? So we can go ahead and put our lid back on top of that one. Now, for this next one, what we want to do then is we're going to basically do the same thing we did and caught it with the cloud. We're going to put several drops of our H2SO4 and several drops of the potassium nitrite together. We're going to put these two chemicals together, and it's going to create the acid rain. We want to make sure we put the lid on fairly quickly. So what we're going to do is we're just going to put several drops like this. Just kind of squeeze it, kind of right as close in the middle as you can get it. And then do the next one. And then put the lid on it, like that. So see how I put this one in the middle and it's fairly close to that one. So as soon as the acid rain starts making, if those chemicals are doing what they're supposed to be doing, that one's going to change colors first.
Soon to not.
And I don't know if you can see it on yours. My color up here is not good enough for you to see it. But the outside edge of my phenol red has already started turning yellow on mine, indicating that it's already becoming acidified. See how it's starting to turn yellow right here? That tells you it's already reacting with the acid rain gas.
Yeah, nice.
And in fact, some of the vapor has already made its way over to my green indicator, because it too is beginning to turn yellow in my dish. Now, you can't see it up here, but in mine up here, my red is almost all gone already. Is your red gone yet?